We have one more part to make and finish out the assembly, then we can do the exploded view. So this is the cap. There's a couple ways we could go about this. It's basic cylinder with a hole wizard tapped hole. We could make this a revolve, and then I'll probably just go with the boss extrude and keep it on the easy side. So a new metric part, and front plane should be okay. And we have a diameter of 12, and we'll be extruding this out 10. And chamfers pretty much go in last, so we're going to pick on the back face, go into the hole wizard, make sure we're in metric, that we're in the, well, there we go, straight tap. And then I want an M6 by 1. And up to next, they show it as a depth of 6. So really, with the 10 millimeter, we want thread to be a minimum of 6. And 9 would be good, not breaking out the backside. We could go a little closer if we needed it, but would like to have that minimum of 6 millimeters of thread. All right, so we're always going to go a little bit deeper than what it calls for. And the drill tip broke out. So let's double check and see what we told it. All right, so the 9 millimeters is to the shoulder, which you can see the cone coming out the backside. So in that case, if I'm going to cut it that close, I'm going to go to full drill tip, and we'll just make it 9.5. So half a millimeter, 20 thousandths on the backside. Doesn't have to be exact to make it work, but I just don't want it popping through. So our chamfer is 1 millimeter, and we go ahead and accept. And then we'll do the file save. And this is going to be the vice jaw handle cap. All right, something that makes sense on the naming. We can switch over to the assembly and insert component existing part, and it will show up. We get it into position and rotate over. So picking the cylinder, control selecting the cylinder. Again, we like the biggest targets. My pop-up is just off the screen, and I missed the lock rotation thing. So if I expand that out, go into the mates, the little center section is not blocked in, so I can lock rotation. And then we need to set a depth. So if we were to get 6 millimeters of actual thread, it would look something. Make sure I can pick that. And go into the mate and set a distance and about 6 millimeters. And what did I lose? Okay, so let's, when I picked that, it kicked out. All right, so we have 6 millimeters. I can flip the dimension. All right, the main alignment, and that wasn't really the desired result, so we want to flip the dimension. Okay, so that pretty much takes care of that one. Let's collapse a couple of these. And again, zooming up just to make sure that I have a good view of what I'm working on. Hold down the control button, left click, hold down on the component, and I typically drag it from the feature tree, or the component tree in this case. So go with the same 2 cylinders and concentric, And then my pop-up, I do want to lock the rotation, and then I do want to flip the mate alignment. So that looks pretty good. And that will set those parameters to where I don't have to go back into the list and into the mate alignments to do it there. And then a distance, we're going to go with the 6 millimeters. So this is the one that I did not need to do the mate alignment. I needed to flip the dimension. All right, so every mate is going to have two possible solutions of alignment, and then the distance and the angle are also going to be able to flip the dimension. All right, so that's our assembly. And next, well, we still have to do the fasteners. So let's hold off on the fasteners. We'll make that a later, well, decision time. I really need the fasteners in there. So we're going to go into the design library. Oh, interesting. I guess I won't go into to remove it. So let's go ahead and remove it, and I will have to point it. So let's go find a design library, since whenever I upgraded or uh, lost it, then we're looking for, and I paused for a second to make sure I know where I was going. So we're going to program data. If you don't see program data, this is that situation where on the view in your Windows Explorer, you're going to need to tell it to show hidden items. So program data, and then we're going to go to SolidWorks and to 2023, and then there is the current design library. All right, I didn't need to do that for this particular function, but since it blinked, I do want it there. So I'm going to go to the toolbox and add in now, and it's going to find the components. There's a lot more than what we need, and in the future we'll turn some of those off. Go into the ANSI metric, bolts and screws, and we're looking for socket head screws, and then the countersunk or flathead. We'll drag the M5s in first, and as we get close, those should snap into place. Lengthwise, let's see what we need here. I'm going to go to the hidden. 10 millimeters doesn't look too bad. All right, with a flat head, 10 millimeters is the overall. Is it going to make it? Okay, so that's the clearance hole, and that's kind of the problem with everything shown. All right, so that's the edge, that's the engagement. That should be all right. And this is going to stay active until we tell it that we're done. So I'm going to be able to put these M5s in. We're going to hit OK. Go to the next one. Make sure it snaps into place. And the next one. And the next one. Okay. And these are going to be hopefully underdefined because they can rotate, but not because they can move away from any of the components. All right, so then we need to go find the M5 socket head cap screws. All right, so a standard socket head. And again, we're looking for that location where it will snap into place. So pretty much along that edge, and it will do an automatic reference. So 8 millimeters. Again, we'll go over to the view to see what the depth looks like, and in the front view. So this one's not even really making it through the part. So on our length, let's go up to 25. Well, that would be great if these guys weren't all the way through. So maybe back to 16. 16 leaves a little bit on the base. Might want to consider on our design element to go back and make that a little bit deeper. Let's take a look at what 12 12 is not quite enough, and 16 is almost too much. So somewhere in there, I would rather have the 16. All right, so like I said, the one in the middle goes through, and the outside two could probably be a little deeper. So either I accepted the defaults and didn't add much to it, or it's pretty much right there on the edge. All right, so I'm just looking for those edges, and as those snap into place, and we go ahead and accept. All right, in previous videos, we've also gone out to a website like McMaster. Let me save real quick. And downloaded fasteners from a website. And that's pretty much the same thing as what we just did. If you don't have the level, if you're at the basic level and don't have the toolbox or some of the other features, then we would be able to grab some of those fasteners from the internet. So we would have to add the mates or add the mate reference manually and go through that process. But I want to go ahead into the explode, and we'll explore those a little later. All right, so explode lives under the configuration, and we don't see it here yet, but I do have it on the assembly tab over, and we're going to go through the steps. So I don't really know what I want to do here, but let's start off without the automatic. Anything that's auto space or automatic has, let's just say, certain issues associated with it that may or may not be to our advantage. So let's do a couple of the basics, and then we'll come back to our parts. So I might, I want to explore some different views, kind of thinking that this will be the one that stays and everything else will move around it. So when I pick an exploded step, we get the orbital. Be careful when you select that you are picking whatever highlights in blue is the direction it's going to go. And then typically I will add more consistent numbers, but don't have to. And I don't want to hit the check mark. I always kind of go up there first, but I need to do a done with that one. And I'm just going to move the jaw and the two screws next. And we can kind of zoom out a little bit, and maybe that one will be 75 and done. These three screws, and that is an instance where I got the rotation that I didn't really want. So let's see if we can clear those selections and try again. Still kind of locked in that rotation though. So this is one that I haven't quite figured out how to get out of. So maybe just hit rotate each. And the distance, let's drop in a 50 and hit tab. It's not really, okay. So sort of did, but didn't really. So I need to add the other two to the list. And then maybe this one goes out 125. So there is some, be careful with the selections on this guy. So I grab those three. Can kind of back out of it, but it's not really easy to as it could be. All right, so let's go ahead and bring the lead screw. This was probably one. Clear that selection. Let's go ahead and try the auto space on one of these. All right, so the auto space is set to center bounding box off of the rear of the bounding box or off of the front. So maybe we'll try the front on this one, and I'll grab that piece, and those two pieces to auto space. All right, and as we drag these, then it goes to the spacing, and not really. That looks a little bit better. Yeah, that one didn't do any better. So a lot of times it is off of the center, and the spacing doesn't look terrible. We can drag that in a little bit and get it closer, and maybe go to 90 and done. All right, and then this one, since we're still in auto space, but it's only one component, it's not really going to do anything with it. So 25 would be good and done. And just to maintain the balance, 25 and done. All right, so you don't have to put those numbers in. They can all look pretty good. Let's bring this one out just a little bit. And probably should have selected it the other way. All right, because the screws did not go quite the way that I expected them. So it's still trying to move that piece. And let's see if that drags those guys out a little bit more. I'm still trying to move that one even though I removed it. All right, so strange to say the least, but that's one of the issues that I have with the auto space. So since we kind of left these screws in place, then it's sort of self-explanatory what's going on there. I will probably just leave the screws there. Oh, and I finally hit the check mark. So we're going to expand out. So again, we're on the feature manager design tree. The property manager switches in and out as we need it. We pretty much don't even notice it. The configurations then have the default configuration and the exploded view once we've created it, and then all of the steps for the exploded view if we wanted to change any of those or go to any of those. But if I edit the feature, then I'm right back into my group, and we'll drop that one down a little bit and give it a number so that we can control it. Let's go Control 7, see what it looks like. That might be a little close. And so if I wanted to edit chain 4, I can see it in the preview. And edit the explode block takes me directly to it. And then our two choices are the linear and the radial. These really don't apply to a radial step, so we'll ignore that. 90 looks a little bit better. Accept it. All right, save it. So here's where the exploded view comes in. Most everybody wants to have a separate file. You do not need a separate file. If I double click, it collapses. If I double click, it explodes. Because it's a configuration, this will show up in the drawing just like it's supposed to. We can collapse it, right click and explode it, and it will do basically the same things. All right, so if you do happen to save this as a separate file, now you're responsible for any update happening in this main body does not automatically transition in the same way over to the other exploded view. And then at some point you will happen to double click on it and your exploded view file will be the collapsed one and your collapsed one will be it's not worth the effort. Just deal with the one file. We save this, and I think we'll call this video good, and we'll pick up with the drawing.